Okay. Hi, guys. Good afternoon. My name is Hillerman Lima, and together with my colleagues Diego Salles and Marlos Rodrigues, we are going to show you our just first new use cases using LoRaWAN technologies. We are from Federal Institute of Amazonas. We are coming from Brazil, state of Amazonas. We are very thankful for being here and different from the other presenters. We are here more to learn than to show something. We have been in touch with this technology just last year, and I want to thank you, Professor Rogério Diógenes, who introduced us with LoRaWAN, and we are here to show some use cases that we are using in Brazil. In the Federal Institute of Amazonas, we are a public school, and we have almost 25,000 students split between high school and undergraduate students. And these students are involved in all the projects developed in the Federal Institute. These 25,000 students are spread in the state of Amazonas in 17 different units of this school, and small cities and big cities. Our unit is located at the capital of the state of Amazonas in a city called Manaus. I don't know if you have ever heard about. We have almost 1,000 active students in our school. Inside our unit, we have a building called Innovation Hub, where we develop projects with the companies in our city. We have almost 550 companies around our city, includes Honda, Yamaha, Samsung, LG, HANA Electronics, Whirlpool, and other companies. And we develop projects to meet their needs with our students. We involve the students in our projects. Our team is formed by multidisciplinary people. We have the professors working on the project, we have the students working on the projects with us, and we have external contributors for development of these projects in Federal Institute. One of the interesting things is that we involve our students in the development of the projects, because there are some technologies that they do not learn in the high school and in the undergraduate courses, but using these projects, they are capable of developing hard and soft skills, and they are helping us on the development of this project. We have been developing some projects with these companies for almost 8 years in the industry 4.0 nanotechnology. We have a laboratory with a lot of equipments for working with nanotechnology and control and automation projects during these last 8 years. And now I am going to invite my friend Diego Salles to show you our first use case using the LoRaWAN. I hope you enjoy.
Okay, thank you, Hilma. Hi guys, I'm showing to you the first use case using the LoRa technology, a LoRaWAN NIC for smart power meter experience that we have in Polo Innovation Hub. The objective is development of a NIC interface, a network interface card using LoRaWAN technology for Nancy smart meters. Nancy is a factory that produce these smart meters and need some, in your portfolio of products, some NICs for communication in different technologies. One of theirs, that is LoRaWAN. In LoRaWAN is the first focus of use case. The overview about what the Hillerman said, then is composed by technical school and undergraduate students that can make some activities with your professors and development of hard and software activities. So the professors are mentors about the students that go ahead with activities in hardware and software to understand and learning some informations and technologies to integrate about the new technology and provide more knowledge about the technology. Visit the factories and understand the manufacturing process is one of the goals about the students to understand what is the factory experience. So here we have the Professor Hillerman with five students that go into the factory, understand the process of fabrication, and understand what is the NIC, and the NIC could be produced for this factory. Just not only view of prototype, but prototype and go ahead to the factory to produce these products, these products. The challenge of this project is the student software and hardware skills. So these students don't have in your curricular these informations about the LoRaWAN or technologies about these communications or telecommunications. And so these students going to the project, the professors and mentors provide informations and technical skills, thank you, and the acknowledgement about the technology, for example, the LMS protocol and LoRaWAN technology that can be understand for my students, the older students, to share more information, and the curricular could be improved in the next step. So the system architecture is the usual about the NIC. The Nansen meter communicate with the protocol, the LMS with end nodes, and nodes with communication with concentrator or gateways that have the TCP, for example, or LoRa MAC communication with the network service and application. All these steps or all these architectures is understandable for the students and for the professors and developments. The development of hardware and software could be collaborators, for example, the Rogério, that have a lot of information can spread for us. Another example about the hardware design that could be made for students and professor is the use of microcontrollers, LoRa radio, memory, and interface, and block diagram. And in the next step, the students made the hardware design, schematics, electronics, with all the components, and understand your functionality requirements that the factory comes to us to develop. The hardware design, for example, here, the board, the PCB that made for students and the developers. Here, the 3D model, and actually the real board that made in Polo innovation. The other thing is mechanical assembly. It's interesting because the students have many areas to understand, just not only hardware, but the software and the mechanical structure to understand this is a prototype for a new product. And this product, we can share a lot of information for transfer this technology to the Nansen factory. The hardware test and validation, just now we try this board with all the other components, creating a network mesh to understand all the data and communications to test and validate and deliver for the Nansen and prototype tested and validated inside of laboratory in Innovation Hub. So here we use the Cayenne system to integrate the communication web system with the NIC board to send the data and understand the voltage, the signal, noise, noise informations, and control of relay about the start or no the transmission of the energy. And now I invite my friend, Marlos, to talk about the second use case.
Thank you, Joe. Thank you, Joe. Hi, guys. I'm so pleasure to be here. Thank you for your attention. The second case is an IoT device platform for automated tracking of products in Amazon rivers. I'll share with you some particularities that we have there in our state. Well, this the objective, of course, is developer of a hardware and software platform use an IoT device to track products transported by boats on Amazon rivers. Why it's so important? Amazon is a state, a huge state, To give you an idea, Amazonas is twice the Texas, which is the second state of here, USA. But we do not have infrastructure. We do not have roads. We have rivers. The large one is the Amazon River, who is the principal on the horizontal way. On these states, it goes from Tabatinga to Parintins, the last area of the state. Here I'll give an idea of how distant it is. Manaus to Tabatinga is about 1,000.1 kilometers. And the people to go there, when they take boat, they of course can go by other ways. Aliás, the only one is to get a plane. By boat, you have to take 5 to 7 days when you go Manaus, Tabatinga, because you go against the flow of the river. On getting back in Tabatinga, Manaus, we spend just 3 to 5 days. But to spend 3 or 4 days taking people, taking cargo, here, the rivers are the Amazon roads. In series, we have the motorcycle. There we have little boats. In series, we have streets for cars. There we have river for medium boats. There, the basis will be a large boat. It's the large one, of 3 floors, not more than this. But usually, it can take cargo, including some cars we can put there. Then we have the trucks there, and we have the ferry boats there. Well, what do you think about applying LoRaWAN there? The distance is huge, but we don't have infrastructure along the river. The series are very distant one from another. It will take very much time with no structures along this river. To put this on, we think about 2 scenarios. One scenario that is very important is when one boat cross another. We have this, and with this, we have an opportunity to change information of location, principally location, but we can have another information. We just now preocupado, worry. Thank you. Worry about the location of the boat and the cargo that it has. When we cross, it's so frequently because there are a lot of boats on these rivers. We'll take the position. Well, they'll take the information from one to another. It's the first scenario. The second scenario is very important is when the boat arrives at a city when we have infrastructure to transmit the information that its own position and the other boats that it gets along the way on the river. Then we take this information and go to the clouds, where we have an application to show to the citizens and enterprises that are interested on this cargo the effective location of them, or the predictive location of them, as we treat DTN network, a network that is not continued with the continued communication. This is an animation where you can see how the data will be transported on this cluster. Right? Imagine that in the part of the river, I have some boats, the first cluster, and the data will be changing between them. When one of these boats take to another cluster, you take all the information of the positions of the first class. In the second cluster, the same, and the data will be taking boat to boat until one boat reaches the infrastructure, and then we send the information to the cloud to be seen and other applications. To get this, we need hardware. So we decided to take ADG Micro. Why? Already it has a Syntec axis radio and microcontroller from ST, who also has Bluetooth. So which we provided to our device. Short and long range connectivity, easy integration in prototype. Of course, it's LoRaWAN multi-region red. And it also, inside his system and package, we have the full range of peripheral interfaces, like UART, SPA, and I2C. On this one, we have a more detailed block to better understand what you're going to construct. It's still a project that we're working on. Well, we need, of course, the GPS to provide the location of the boat. Then we need an EVM to store the data, the position of the boat that the device is in, or the other boats that it meets along the way. And, of course, provide the communication V2V, vehicle to vehicle, with the boats who will cross, its device will cross along the river. And, of course, the V2I to reach the infrastructure, the gateway LoRaWAN, where we get the information to the cloud. Well, this was the project. If anyone, we could answer some answers now. Any question? No questions? So, I have a question here. Why? How many units you guys deployed? How many units we're going to develop in the project? Well, it's not too much, because the objective of the project is not to put it on the market yet. It's to develop a prototype. I think we're going to be just 20. It will be enough. We're planning to do this on Manaus to Tabatinga, the longer range we have there. Also, we have a partner who actually is selling the tickets and these boats. And we think he is going to take this device and implement in all the boats in this world.
We are working together with a professor in Manaus, and he has a job developed using radio transmitters in the Amazonas rivers, and he will be part of the team. His name is in the end of the presentation to help us with this. That's the idea. During the trip, they will cross with a lot of boats, and they will get the information for all of boats in the way they are getting the trip. And as soon as he gets an infrastructure, our idea is to transmit. We have cities between two very distant cities. We have another along the way. And we are, our intention is to update the information along the trip. Yes, it's Class C. We are going to get the energy from the boat, so it has to be always on to listen if there is another boat around. It operates in Class C. We are using two principles here. From boat to boat, we are using just LoRa with a proprietary protocol. And as soon as we get near infrastructure, we are going to switch to LoRaWAN. So it's not implemented yet. It's just an idea. There is a possibility for using two SIPs in the same board, one always point-to-point, and another looking for an infrastructure to transmit the data.
So, thanks to everybody. I really enjoyed.
Thank you.